Hello everyone, this is the second way to find the critical value. This time we're gonna use a t distribution and we will use a calculator to do that. Okay, so example number 1, we're gonna use t distribution to find a critical value. So we have here use t distribution, and we will use a critical value, and because we're using a t distribution, we will say t sub alpha over 2, meaning divide by 2 for 90% confidence interval. And here we need n. Our n is 20. Alright, so again, we're gonna find the critical value for 90% and our n is 20. So again, go into 90%, and you know 100 minus 90, we have a 10%, divide by 2, we have 5% for each side, and 5% is 0.05 in decimal. Okay, so this is what you need. These are the informations you need in order for you to proceed. Okay, so let's make a bell curve for that. Okay, the highest peak will be our mean. Our mean here, will say our mean is, I mean the middle one. The center will be our mean, and this should serve our axis of symmetry. So let's say this line will be towards the left. That should be our 0.05, and that is our 5%. And then symmetrically, well, our bell curve doesn't look symmetrical. Okay, so symmetrically we can assign this approximately as our line. This is for towards the right, so the arrow should go towards the right. So this is 5%, and this is equivalent to 0.05. So this is our t. Let's make this smaller. The axis will be named t. Alright, so here we will be using the I and V. I and V t, and it has two values. Since our n is 20, then n minus 1 is 19, so we will use the 0.05 and then 19 because n minus 1, and to get this value, and Vt, we will use 0.95 because from here to here is 95. The area is 95 because this is 90 plus, well, this is 90, so that will be our 0.90. So to get this value, 0.90 plus 5 is 95, and then of course n minus 1 is 19. Okay, and you use your calculator. Reset second plus 712, so it's clean. So now use second function, distribution. Now go down, INVT. Okay, and then our area to the left is 0.05, comma, and then our degree of freedom, well, our n is 90. No, our n is 20. 20 minus 1 is 19. Then you'll get negative 1 point. We're just gonna get we round this up, 1.73, negative 1.73. So this is negative 1.73. And then you know that it's symmetrical, so this becomes positive 1.73. But let's try. Let's see if it's really the same answer. So second function, distribution, go down, and then now this time 0.95 is the area to the left, and degrees of freedom is 19 because n minus 1 to get the degrees of freedom. So we have, you see, positive 1.729 or 1.73. So this is the same thing. But you don't have to do that because you can also use the concept of symmetry. So any question, guys? And hope you learn something. Thank you.